Hello guys, welcome to Amazing Engineering, and today we will see how to calculate the power generated by a wind turbine using OpenFOAM. For this purpose we will follow the BETS analysis, where we supposed to have a monodimensional, incompressible and axial flow, and we don't consider the basement of the turbine. So if we calculate the velocity referred to a section in front of the turbine and a section on the back of the turbine, we can calculate the power generated by the turbine multiplying the mass flow and the half difference between the squares of the velocity. So we can create the mesh and the domain using Salom, where this is the turbine, this is the outlet section, the frontier section and the inlet section. After exporting the mesh as a UMV file, we can set the parameters of the simulation in the same way we did in the previous video of aerodynamic analysis. So I will leave you the video in the description, and we can open ParaView, where this is the old domain, and in order to have a better view of the case, we can create a slice of the domain using a normal vector along the z direction. So what we have to do is to extract the velocity profile on a section in front of the turbine and on the back of the turbine. For this purpose we have to click on the plot over line command, but before this you have to select the old domain, because if you click on plot over line selecting the slice of the domain, we can get no data from the simulation. So click on plot over line, set the line along the y direction. We can put a line, for example, at this distance from the turbine. Click on apply. Now we have to set the parameters of the plot. For example, we can set the x velocity along the x direction and along the y direction the arc length. In order to extract this profile, click on Save Data, and we have to save this file as a CSV format. After that, we have to do the same operation for a section on the back of the turbine, and after that we have to save the true data. We have to save the data on an Excel file. We can use as a reference value of velocity the average value of the two profiles. Then we know that the density of air is equal to 1.225. We can suppose to have the first section equal to 28 meters square, and after calculated all the data we need, we can calculate the power using this simple formula, and in this case it is equal to around 320 watt. Okay guys, this is all for today. I invite you to subscribe on my channel and see you for the next video.